Hi guys, welcome to my channel Maths and etc. Funda. Today we are going to start progression. We will study today different types of progression, definition, formula, real life examples, approach towards problem, and finally activity. So first we start, what is progression? Progression means a sequence, and it has synonym also series. So what is progression? Progression, sequence or series is a collection of terms arranged in a specific order where each term is obtained according to a rule. Suppose I am giving here an example 1, 2, 4, 8, 16. Here the first term, second term, third term, fourth term, fifth term and so on all are obeying a certain rule. How? See here, first term is 1, second term is 2. So first term, whatever is first term, second term is twice of first term, and the third term is twice of 2, that is 4, that is twice of second term. Fourth term is twice of third term, like this. So this series maintain a specific rule, that is each term is twice the previous one. So it's a progression series. It is a progression. In the second example 1, 8, 27, 64, here the first term is 1, that is 1 cube, second term is 2 cube, third term is 3 cube, fourth term is 4 cube. So like this it maintains a specific rule. So here series obeys a rule of cube. So types of progression. Progression is generally two types. Arithmetic progression, that is AP, and geometric progression, that is GP. Understanding the math concept of arithmetic progression. So, what is the definition of arithmetic progression? Let me say, when a sequence has a constant difference between the successive terms, it is called an arithmetic progression, often abbreviated to AP. It means there is a relation between two successive terms. Here is an example. In the first example, there is a series 3, 6, 9, 12 and 15. So here first term is T1 equal to 3. Second term is T2 equal to 6. Third term is equal to 9 and so on. So here the second term equal to first term plus 3. third term equal to second term plus 3 like this. So it obeys a rule like common difference will be 3. Let's take another example. For the second example, first term is 7, second term is 2, third term is minus 3, fourth term is minus 8, fifth term is minus 13, like this. So here the first term T1 equal to 7, T2 equal to T1 minus 5, T3 equal to T2 minus 5, and ultimately the Tn, the nth term will be Tn minus 1 minus 5. So here the common difference is minus 5. So this series is also obeying a certain rule, that is every term is between the two terms there is a difference of minus 5. Okay, student? Now student, we are going to get the general expression for the nth term in AP series. So let's take the example here, the second one, this one example. Okay, so first term here the A, second term A plus D, third term A plus 2D, fourth term A plus 3D, like this. Series is like this, where common difference is D. So in this case, here, look here, in the first example, it is A, Tn equal to A plus 1 minus 1 multiplied by D, that is T1, term 1. For the second one, T2 equal to A plus 2 minus 1 multiplied by D, that is 2 is equal to 2 here. T3 equal to A plus 3 minus 1 into D. So here 3 is here. So for the 10th term, it will be Tn equal to A plus n minus 1 multiplied by D. So it is like this. So this expression is here Tn equal to A plus n minus 1 into D. Clear? Okay. Next we are going to get sum for n term. Let's call it Sn. Okay. So first term here A, second term here A plus 2D. We take this series second one also here. A, A plus 2D, A plus D, A plus 2D, A plus 3D. For this, we have to find out the sum of n numbers. So here the first term in this series, first term is A, and the last term is L. So here we have to find the average. So average is, how do I find average? So average equal to, in this case average equal to A plus L by 2. Okay, and if I want to get the sum of all n terms, we have to multiply it by n, number of terms, So number of terms multiplied by average, we get the full sum, the total sum, total. So here n multiplied by a plus l by 2, we get the sum. Now substituting value of l here, in here we get this expression, Sn equal to n by 2, 2a plus n minus 1 into d. This is the general expression for the summation of n terms. Okay. Now we are going to, now we take some real life examples of AP. We all saw that during cab ride there is a fixed price for meter down and every 1 kilometer costs a fixed rate. Late for rupees 25 for meter down and rupees 5 extra for next 1 kilometer and so on. So the fare will be like this. For the first kilometer it will be 25, for the next kilometer it will be 30, and for the next 1 kilometer it will be 35, like this. So it maintains a series 25, 30, 35, 40, like this. So here is the first term is a and the common difference is 5. So it maintains a series AP 25, 30, 35, like this. Next, take one more example. An auditorium seat arrangement. In an auditorium, the arrangement of seats, say, first row has seat 14 seats, and the second row have 2 more seats, that is 16, and the third row has 2 more seats, that is 16 plus 2, 18, and so on. The series is like 14, 16, 18, 20, like this, and there is a common difference too. So it maintains an AP series. Next, take one more example, ladder step. We all see ladder. So here in ladder, the first step, suppose in 100 centimeter, and the next step will be in 95 centimeter, and the third step is in 90, and so on. So here series is like 100 centimeter, 95 centimeter, 90 centimeter, like this. So here the first term is 100 and the common difference is 5. So it maintains an AP series. Let's do some problem. Look at this math problem. Now student, it is time to solve some problems. Look at the first problem. Find the sum of the first 12 terms of the series 5, 9, 13, 17, so on. Here we have to first observe the values are given. Here the first number, that is a equal to 5, and there is a constant common difference between the two successive terms, that is here d equal to 4. Now we have to find the n. Here n is given also 12. So now we have to find out the sum of 12 terms. So put the value here, Sn equal to n by 2, 2a plus n minus 1 into d by 2. So here the first, substituting the value of a, d and n, we will get the result 324. Now go to the question number 2. Three numbers are in arithmetic progression. Their sum is 15. Their product is 80. Determine the three numbers. Instead of writing the first number a, we can write the first number like a minus d. Second number, second term is a and third term is a plus d. Now putting the value of a minus d, a and a plus d, that is equal to 15 here. So here a equal to 5. Now we'll build the second equation, that is the product of the three numbers is 80. So a minus d and a plus d equal to 80. Substituting the value of a here, we'll get the value of d. Now, so the numbers, three numbers are 5 minus 3, 5 and 5 plus 3, that is 2, 5 and 8. Now move to the question number 3. An oil company bores a hole 80-meter deep. Now draw the bore. It is 80-meter deep. Okay, think like this. Estimate the cost of boring if the cost is rupees 30 for drilling the first meter. So first meter, this is first meter, first 1 meter. Next second meter, second 1 meter cost equal to rupees 2. And first meter cost is 30. So second meters, for the first two successive meter, we have to pay rupees 30 plus 2, that is 32. For the next 3 meter, we have to pay 32 plus 2, that is 34, like this. So series will be like this, 30, 32, 34 and so on up to 80, because we have to bore 80-meter deep bore. So we have to find out the total cost. So here a equal to 30, d equal to 2 and n equal to 80. So substituting value of this, will get the result how much we have to pay for drilling the bore. That is Rs equal rupees 8,720. Understood everyone? I think the problem is clear. These three problems are clear to you. If you have any doubt, please write in the comment box. Now, let's understand the concepts of geometric progression. First, listen the definition of geometric progression. In geometric sequence, each term is found by multiplying the previous one by the same constant. If the first term is a and the constant, that is common ratio, is r, then the series will be like this: ar square, ar cube, like this. When sequence has a constant ratio between the successive terms, it is called geometric progression, often abbreviated to GP. The constant ratio is called common ratio and it is denoted by R. Now take the first example. Here the first number is 2, second number 4, third number is 8, fourth number is 16, and fifth number 32, and so on. If we multiply the first number with a constant common ratio. Here it is given. Here it is given 2. Then we'll get the second term. So 2 multiplied by 2, that is 4, is the second term. So first term here 2, second term is first term, term 1 multiplied by 2. Third term is second term multiplied by 2, like this. So here first term is 2, second term will be term 1, that is 2 multiplied by 2, that is 4. Third term will be second term how much? Second term is 4. So 4 multiplied by 2, 8, like this. So here first term is 2 and common ratio is 2. For the second example, it is given 27, 9, 3, 1, 1 by 3. So here the first term is 27, a equal to 27, and the constant common ratio is 1 by 3. And for the nth term, if I consider nth term is Tn and n minus 1th term is Tn minus 1, then constant common ratio will get R equal to Tn by Tn minus 1. Now it is time to find the general expression for the nth term of the GP. If the first term of the GP is A and the common ratio is R, so the series will be like this: AR, AR, AR square, AR cube, like this. So this series can be written like this: AR, AR, the first term will be AR raised to power 1 minus 1, second term AR power to the power 2 minus 1, third term AR to the power 3 minus 1, and for the nth term it will be AR to the power n minus 1. So the nth term will be AR. So nth term will be AR to the power n minus 1. So this is very important. You have to remember this expression: Tn equal to AR to the power n minus 1. Now, like AP, we have to find out the sum of n terms in GP. So take the series like this: AR square, AR cube, AR to the power n, and for the sum of nth term Sn equal to like this. So multiplying both sides by R, we will get this expression 2 and this is expression 1, and substituting we have to minus equation 2 from equation 1, we will get the result Sn equal to A 1 minus R to the power n by 1 minus R, which is valid for when R is less than 1. That is, when R is fraction, we will use this formula. We will use this formula, this one. And now, subtracting equation 1 from equation 2, we will get the result Sn equal to like this, which is valid for when R is greater than 1. So, when the whole number is given in the series, we will use this second formula. And if the common ratio is fraction, so we will use this equation. So it is very important you have to remember these two formulas to solve any problems, geometric progression problem. Now let's look some real life examples of GP series. Annual size of a population constant rate means annual size of population is growing like GP series. So the if any village there is there was some population that is 1000, in the next year it will be twice, that is 2000, and next on the third year it will be 8000, like this. So it maintains a GP series. So first term is 1000, second term is 2000, third term is 4000, and fourth term is 8000, like this. So here first term is A, that is equal to 1000, and the constant common ratio is here 2. Now look at the second example, value of money. Value of money increasing in your bank account at a fixed interest, say 10%. So in the first year it is rupees 100. You keep 100 rupees 100 in your account, and in the first year it will be 100. In the second year, in the beginning of the second year, it will be rupees 110. In the beginning of third year it will be rupees 121. Fourth year it will be 133.10, and in the fifth year it will be 146.41. This is an example of compound interest, as previous year's interest is added to the total and included in the following year's calculation. So here constant common ratio is 110 divided by 100, that is 1.1. Now take another example, that is bouncing ball. You all saw bouncing ball, how it is bouncing. So from maximum height, I throw the ball in the ground. So maximum height, say when I throw the ball on the ground, it was 100 meter. Next, when it bouncing back, it will lose its energy, and say it will achieve 3/5 of its height, that is 100 multiplied by 3 by 5. In the next bounce, it will achieve 100 multiplied by 3 by 5 square. So like this, it lost some energy, and after when it bounced back, it maintained a GP series. So bouncing ball is also obeying the GP series. In radioactivity level, the product of the product isotope, it decreases and maintain the GP common ratio. Now it is time to solve some problems on GP. Look at the question number 1. Which term of the series, the terms are like this: 2187, 721, 29, 243, and the last term is 9. We have to find out which term is 9. So here the first term, A equal to 2187. First we have to see which is given here. The first term is given, and the common ratio here, we can find the common ratio here, that is 1 by 3. So how do you find common ratio? So R equal to T2 by T1. Here T2 is 729 and the first term is 2187. So here common ratio is 1/3. R equal to 1/3. Now put the value here 1/3 and A, you will get the number of terms. Here n is the n equal to 10. So the 10th term will be 9. Now look at the second example. In a geometric progression, the sixth term is 8 times the third term, and the sum of the seventh and eighth term is 192. Determine the common ratio of first term, sum of the fifth to 11th terms inclusive. So here third term equal to AR square, and the sixth term is AR to the power 5, because you know how to find out term third term, that is T3 equal to AR to the power 3 minus 1, that is AR square here, and sixth term is AR to the power 4. Now put the value here. AR to the power 5 equal to 8R to the power 2. So substituting the value, we will get the value of R, that is here R equal to 2. And for the second term, first term, we have to find out the first term. So here sum of the seventh and eighth term is 192. So eighth term is AR to the power 7 and seventh term AR to the power 6 equal to 192. So put the value R equal to 2. Here we already get the value R equal to 2. Put the value R equal to 2. We'll get the value A. So here A equal to 1. So first term is 1. Now we have to find out the sum of the fifth to 11th terms. So sum of the fifth and 11th term inclusive given by S11 minus S4. So S11 equal to this, we will use the formula A r to the power 11 minus 1 by r minus 11 minus A r to the power 4 minus 1 by r minus 1, that is r here 2. Now put the value here, we will get the result. Now what is this problem solving? Now we do some activity on AP. AP problems activity is given here. So here 4 series are given. We have to find out this is are obeying AP or not. Take few color marble papers and cut the papers like 2 centimeter, 4 centimeter, 6 centimeter, 8 centimeter, 10 centimeter. After that, mount them in a white sheet and observe between the two successive papers, and you can observe that there is a common fixed difference between two successive terms. Here it is 2 centimeter. So here first term is 2. so it is 2. This blue marble paper is of 2 centimeter. Next, this orange marble paper it is of 4 centimeter. So it is the common difference is 2. Next, the third term is 6. So this gray color paper is of 6 centimeter. And look, the difference between the orange paper, length of the orange paper and the gray paper is also 2. For the fourth term, it is 8. It is yellow color, and you will get that the common difference here is 2. And for the fifth and fourth term, there is a common difference of 2. So it maintains a AP series. Now, the second series is given here 3, 5, 6, 7, 11. Cut the paper into 3 centimeter, 5 centimeter, 6 centimeter, 7 centimeter, 11 centimeter, and mount again on a white paper. Observe that there is no constant common difference. There is no constant common difference. So difference between 3 and 5, the first it is 2. Difference between second term and third term, it is 1. Difference between third and fourth term, it is 1. Difference between fourth and fifth term, it is 4. So there is no constant common difference. So solution for the second example is not obeying the AP series. Now for the third question, the terms are given like this: 1, 5, 9, 13 and 17. Here again cut the papers according to the first term, second term like this, and you mount it and observe it is maintaining the AP series, and there is constant common difference 4. And for the fourth question, the terms are like this: 4, 7, 9, 10, 12. There is the difference between first and second term is 3. Third and second term it is 2. Third and fourth term it is 1, and fourth and fifth one it is 2. So it is not, there is no constant common difference. So it is not obeying the AP series. So you understood how to solve this AP series, whether the numbers maintaining the AP series or not. How do you calculate? How do you solve? Now look at the GP activity. Verify the following series in GP or not. So series is like this: first one is 2, 2 squared, 2 cubed, 2, 4, 2 to the power 4, like this. Now let's solve this. Here the constant common ratio for the first case it is 2. So the series is in GP. For the second question, it is 6 by 2, 18 by 6 equal to 3 is constant. So the series is in GP. And in the third question, the common ratio is not constant. So 10 by 5 equal to 2, 15 by 10 equal to 1.5, it is not constant. So the series is not in GP. I think you understood the GP activity. Now take another GP activity. See, this paper, this is a square paper. Take a square paper. Say this is term 1. Now you fold this paper into 4 equal parts. So each part is 1/4. Okay, the red portion. Each part is 1/4. Now again you fold this 1/4 parts equal to 4 equal parts. So each part will be 1/16. The blue portion. This blue portion. Again you fold this into 4 equal parts. So each portion will be 1/64. And next part will be 156 if you fold it again for 4 equal parts. Next each part will be 156. Again you fold this paper into 4 parts, 4 equal parts. It will be 1/104 like this. So it maintains a GP series. Here the first term is 1 and the constant common ratio is 1/4. So the GP series will be like this here: 1, 1/4, 1/16, 1/64, 1/256, so on. I think you enjoy this GP activity. Now this is another GP activity. Some problems are given here: problem 1, problem 2, and problem 3. In the beginning, in the first question, you all observe that the first number was 2. After 1 minute, it was 3. 3 dots are here. After 2 minutes, 9 dots are here. After 3 minutes, 27 dots are here. So here, the series is like this: 1, 3, 9, 27, 81, 243, like this. And here the constant common ratio is 3. Because term 2 here 3 and term 1 is 1. So 3/1 is 3, constant common ratio. Now observe the problem number 2. In the beginning, it was 40 number of dots. After 1 minute, it is now 20 number of dots. And after 2 minutes, it is now 10 number of dots. So terms will be like this: 40, 20, 10, like this. And it also maintains a GP series, and here the constant common ratio is 20/40, that is half, 1/2. And for problem number 3, take here the first 3 dots here. Again, after 1 minute, 3 more dots here. After 2 minutes, it is now 12 dots here. So here first term is 3, second term is 6, third term is 12, fourth term is 24. So here the series like this: 3, 6, 12, 24, 48, like this. Here constant common ratio is 2. So it maintains a GP series. Is everything clear? Feel free to make an open discussion for the question and clarification before proceeding. If you have any doubt, you send in the comment box. So, summary of today's class is: recap. Recap 1, definition of progression and its types, how to develop the summation formula for both AP and GP, practical examples of AP and GP and how to solve problems, and finally activities for AP and GP. This all for today's session. Thank you, student. Thank you for watching.